Um, cool. So right now we're just gonna simplify this sets, and then the next four questions we will be rationalizing. So remember, for rationalizing, we're just rationalizing denominator. Cool. Like this one, guys. I always say, this problems really don't complicate them. I think better use the rule that you remember, or maybe the rule that you know very well. It'll be nice for you to know the rule that applied to a particular problem directly, but if you happen to have forgotten it, just use the ones that you know. Try to manipulate the problem. um, yeah, if I made an interesting question, I'll try to show you how I did that during my times. Cool. First question, question number one. Like I said, there are many ways of doing it. I'm just gonna illustrate right here, right? The first one, first person, person number one, they can say, oh, we have the same set. So I guess I can just say I have this right here, 16 multiplied by 4, right? This is accurate. And then, of course, you realize this, you have your 3 here is 4, times 4 times 4, which is 4 to the 3, and then the 3 cancel each other, so you basically have what you're gonna have. Your answer is 4, and of course it comes from 3 divided by 3, which is just 4, right? That's the first person. The second person can be like, okay, so I have this, and then I have 4 to the power of 2 multiplied by this one over here, and then now they break it down into, so you have 4, 2 over 3 multiplied by 4, 1 over 3, right? Of which same basis, we add the exponents because we are multiplying. So that is 4 to the power of 2 over 3 plus 1 over 3. Denominators, your denominators are the same, so you just add straightforward. That's 3 over 3, which is just 4. So there, like I said, guys, there are just many ways of doing these problems. Don't be stuck on one method, yeah, just always remember there's always a different way of doing problems, right? An example, another good example is this one. The person can realize and say, okay, cool, I have the same radical signs with a degree of 2, so I can just say I have, maybe let me do this, see if we can have multiple solutions. So the first person can say, cool, I'm gonna have this, then it's 12 over 3, which is what? Which is, the answer there is 4, which is gonna be 2, from 2 to the power of 2 over 2, right? Because here it's 2, right? That's the first person. The second person can then say what? The second person can then say, okay, cool, what do I have here? I have 12, which is 12 is a product of 2 squared. Let me go step by step. 4 times 3, that is 12, right? But I mean, come on, guys, you are doing grade 11, so it's fine. So it's 2 squared multiplied by 3, that is what? That right there is 12. And then I have this guy over here, then I have my guy over there. So now I can say, for the numerators, I have what? I have 2 to the power of 2 over 2, right? Cool. I feel like I'm rushing this problem. Let me try to do this. Let me try to do this. I feel like I am rushing this problem. So I'm gonna slow down a bit and say I have yes multiply by yes, right? And then I can just say divide by, yeah. Then right here, I mean, you can go the long way, which they're gonna divide each other, but you can just do this, and right here it's 2. The answer is just gonna be 2. From, of course, 2 to the power of 2 over 2, which is 1. Yeah, So yeah, that's it. Let's go to the next problem. Next one is very interesting. It's very interesting. So okay, I'm not gonna do it in multiple solution just to save time, but actually there are many ways of solving this one as well. I don't know. I didn't decide which method to use. So like when I see these problems, I'm like, oh my god, there's like a lot of solutions for these problems. Where do I start and all of that? So this one we can start in the brackets or we can start outside. It doesn't really matter. But let's just start in the brackets. You have 1 over a minus 1 over b, right? You can just try to make sure that you have the same basis. How do you do that? You say 1 over a multiplied by b over b minus 1 over b multiplied by a over a, right? Then you have 1 over then you have b over ab minus a over ab. Damn. So minus 1, and of course you have b minus a over a b, right? Minus 1. So this minus 1 is very interesting. Remember guys, if I have x to the power of minus 1, I just have that, right? Or just in simple terms, I have 1 divided by x. So this part is important because it's what I'm gonna do next. So I can say I have 1 divided by b minus a all over divided by ab, right? Laws of division with fractions is that you're gonna change that division sign into a multiplication sign. Actually, I don't know the name of that law. I just know that's how we do it. Yeah, and your answer is just ab all over b minus a, and then you're done. You are basically done, right? So cool. Let me erase this part to make up space for the last question on the simplifications. So right here, how do we start? I mean, you can double your brackets and start doing your FOIL, stuff like that. You're gonna get the right answer, but you can also like realize. So let's talk about 20. 20. You take 4, you multiply it by 5, you get 20, right? And from 4 you take 2 squared, you multiply it by 5, you get 20, right? So what can we do? Let's just say this 2 to the power of 2 multiplied by 5 minus square root of 5, right? And bam, to the power of 2. Now you break this up. You have that guy and 5. Yep, and here I mean you can just take out 5 as a common factor, or do it the way I'm gonna do it. It's still gonna get the same answer. You have 5 minus root 5 squared, right? So just for simplifications, this look exactly like 2x minus x, right? Don't be confused by these guys over here. This is just the same thing, which of course your answer is gonna be x. So from here the answer is gonna be root 5 to the power of 2, which is gonna be 5. Very, very simple, right? Cool. Let's quickly do rationalizing and we'll be done with this section. Cool. So when you rationalize, you're rationalizing the denominators. It's easier when you're working with a rational denominator than denominators that have sets. Like as you can see here, we have sets. So yeah, it's just easy to work with the rational denominators. So that's the whole concept of rationalizing. That's what we're doing right there. Cool. So the best way also for me to show you how it works is to do a problem. I'm going to simplify this guy over here. So remember, you want to eliminate the radical sign. You want to eliminate or remove the sets of your denominator, right? Of which in this question, how do I do that? If I multiply by root 2 over root 2, right? A product of two roots, if I have this, the answer is just gonna be 2. They're gonna eliminate each other, right? So that's the whole idea right here. So let's continue. Of course, this one is gonna multiply both these guys. So you have 2 times 3 plus you have 2 times 7, and you have 2, right? And of course you can just say you have 6 plus 14 and 2, then you're done, right? Yeah, nothing really interesting with this problem. Very interesting one is actually number 2 and number 4, I believe. So let's work with number 2, see where we get. So you want to eliminate this. When you have a binomial, this is now where I think you guys know from grade 10 what difference of two squares looks like. If you have a difference of two squares, is when you have two squared numbers and you just subtract which are subtracting each other. Like if I have 4 minus 16, this is difference of two squares, right? I can have x squared minus 25, difference of two squares, because there's squared number, squared number, squared number, squared number, difference of two squares. So I want to make my denominator, I'm going to multiply my denominator with something like this. In this case, let's start with the denominator. So it's root t minus, look here, it's positive, I say minus, and then it's 2, right? And then remember, so that we don't change anything, you don't change anything if you just multiply by 1, which is what we are doing, right? So, and if you have a product of these guys, you don't have to do the FOIL. I mean, you can do it, but it's just gonna waste your time. So basically how you do this thing, I will start with the denominator. You're gonna have t minus 4, and then you're done. Basically you're just done, right? Then with the denominator, that's where you can do your FOIL. You have t root t, you have minus 2t minus 4 root t, and then plus 8, and then you're done, because there are no other common factors. Yeah, if you don't know, maybe didn't see what I did right here, I'm gonna do it in the next chapter. And yeah, but also I can just say, if you didn't see what I did, I'll say just do your FOIL, and you'll see that we'll get to the same answer. As to what did I do, how did I do it, you will see in the next chapter. Cool. Number 3, I have 2 over root 3. I'm just gonna change that, and I have this guy over here, right? No, that is wrong. This is 2. Cool. So now I can just say what? I can just say I have 6 over 3 multiplied by 2, which is 6 root 6, which of course, to eliminate that side, I just do this. Then my answer is 6 root 6 over 6. Cool. And then of course I have a common number. Which is 6, numerator, denominator, so they cancel each other, and my answer is 6. Then I'm done. The last one before we solve for x is going to be number 4. And number 4 is very interesting as well. Number 4, we have 1 minus 1 plus root m. So with that minus, I have something like this. Alright, let me remove my guys. I have something like this, and now, like we said, we're going to multiply with This right here it's minus and then root m. Then my god, that's 1 minus root m. Numerators are not really complicated. It's just gonna be this guy, 1 minus root m. And then denominators are also not very complicated. The answer is gonna be 1 minus m. And like I said, if you don't know how I got to this answer so quickly, wait for chapter 2. Otherwise, you can just do your FOIL. You will see that it's gonna land you with the same answer as me, right? So this is how it's done. We're gonna do the last section under chapter 1, and then we'll be ready to jump into chapter 2. So good luck and all the best, and see you in the next video where we'll be solving for x using exponents and sets.